Today's experiment is experiment number 48 for 9-Benzal and 9-Benzyl fluorene, and sometimes referred to as the Aldol Cannizzaro type reactions. And essentially we're forming new carbon bonds, either single or double bond. We're starting off with fluorine, adding benzaldehyde, and I'm noting the quantities here because we have two parts we're doing, part A and part B. So there's different quantities of the reagents involved. In the presence of potassium hydroxide and benzyl alcohol, again 20 milliliters, we're going to form, after reflux for 90 minutes, we're going to form 9-Benzal fluorene. And you notice the carbon-carbon double bonds that are formed. Benzal fluorene has a melting point of 68 to 74 degrees. The only thing we're going to do for this experiment is to calculate the mass of 9-Benzal fluorene that we prepared or were able to make, and then calculate the percent yield based upon the amount of fluorine that we started with for both part A and part B. So this requires a 90-minute reflux, so we're going to start this part of the experiment first. Part B, we're starting with fluorine as our initial reactant. We're going to go through the process and make 9-Benzal fluorene, which is this, same thing, and this becomes an intermediate step in the reaction process because we're going to vary the amount of benzyl alcohol, 10 mils versus 20, and we're going to vary the amount of benzaldehyde, 3 drops versus 4 milliliters. Those differences and the fact that we're creating an intermediate, 9-Benzyl fluorene, and we're going to end up with 9-Benzyl fluorene. And again, carbon-carbon single bonds versus carbon-carbon double bonds. This requires a 60-minute reflux. And again, we're going to calculate the mass of product that we obtained, calculate the percent yield based upon the mass of the fluorine that we started with. So mass and percent yield. And then the formal report will be written with these processes in mind. I have the chemicals for the reaction pre-measured, pre-weighed, and we're going to set up over here with the reflux apparatus. And I have my 2 liquids measured. This is part A of the experiment. So we're using a larger apparatus for reflux compared to what we used previously. We have greater quantities of chemicals, but it's the same principle. It's countercurrent flow. The water comes in to the outside cooling chamber, and as the vapors come up into the reflux area, they condense and fall back down, and the reaction takes place. So we have to reflux for an hour and a half. So again, all these chemicals are pre-weighed. Here is fluorine that's weighed specifically for this measurement. Here's our fluorine. When you're preparing these samples, it's good to add the powder first because You don't want the powder to catch onto the side of the vessel. This is the sodium potassium hydroxide, which picks up moisture. We're going to have to get a spatula to help put it into the flask. So we added the fluorine, and now we're in the process of adding the potassium hydroxide, which has been sitting in the weighing container for a few minutes. And what happens typically with potassium hydroxide, it picks up a little bit of moisture, so we have to kind of force it in. And now we can add our benzaldehyde and our benzyl alcohol. In the quantities that I already measured. Good. So I have a good mix with a reflux and boiling. You always want to add a couple of boiling chips. Sometimes we weigh these boiling chips in case the weight comes into the end of the process, or we can just pick them out with tweezers at the end. Important to get your water flowing. Nice steady flow of water for the cooling. Attach your reflux apparatus to the flask. And now we'll wait for reflux to take place, and as soon as that starts, we'll count our hour and a half of reflux, or 90 minutes. So this is part B of the experiment. Everything is pre-measured as before. The benzaldehyde and the benzyl alcohol mixed. So this is going to make benzyl fluorene, whereas part A is making Benzal fluorene. Okay, so this is part B of the experiment. I pre-weighed the fluorine. We'll add it to the vessel. And we'll also add the sodium hydroxide, again, which picks up moisture, so we have to kind of force it in a little bit. That's pretty good. Add our mixture of benzaldehyde and benzyl alcohol in different quantities from part A. Add our couple of boiling chips. This is the only substance you handle with your hands because it's just a rock, limestone. Start our heat. Put our vessel in here. Make sure we have nice water flow through the condenser. Nice steady flow. And now we can put this attach the reflux apparatus to the flask and wait until we get reflux and then start counting the 60 minutes. Okay, the reflux process has started. We see that the liquid is running down the sides of the flask. Once that happens, we know that the vapors went up into the condenser. They condensed and started dripping down. So now we started our 90-minute time from this point on and let the reaction take place. This is part B of the experiment. Now it's undergoing reflux. As you can notice, the liquid is dropping back into the flask, so the reaction mixture is condensing in the tube and dripping back down. Now we simply just have to wait 60 minutes for the reaction to go to completion. Okay, now we've reached our 60-minute time for the reaction. We'll turn off our heat. Let this cool for a minute. There we go. We'll just let it cool. Okay, so we've let it cool for a couple of minutes. We're going to bring it over here to the ice bath and let it cool for a little bit longer at a cooler temperature and go through the next couple of steps. Suction filtration. We've weighed the filter paper so we can get the weight of the product at the end. So it's cooled in ice bath till about room temperature, and you notice it formed a solid. So it's a little difficult to transfer, but we'll be able to do it. Got a lot of product, actually. Put 10 milliliters of water. Get a lot of it out. We can use a little extra water because we can use that in the suction filtration anyway. And we'll make sure, because we're quantitating this this amount, so we want to make sure we get most of it out. We'll see how much product we're able to get. Sometimes we don't cool it until after we transfer it, but we did it this way this time. Okay. Now we want to turn on, we may have to try to get some more of that out. Turn on our vacuum. We've already weighed the filter paper. And we're going to actually try to get some more of this out before we transfer it. There we go. That's what we wanted to do. That's good. Now we can transfer it to our funnel.
Can I take it water off, please?
Okay, so that's the finished product, part B, which is 9-benzyl fluorene. And we want to let it undergo suction filtration for as long as we can. And then we'll transfer the product to a watch glass and put it in the oven for a few minutes to dry. The melting point of 9-benzyl fluorene is around 68 to 74 degrees C. So the 90-minute reaction time has completed for part A. So we're going to remove, we don't need the heat anymore, remove the vessel from the heat, and that comes off nice and we'll let it cool for a few minutes. The last step in the process is just to cut the water flow to the condenser for part B and cut the water flow to the condenser in part A, since we removed the distillation flask from the heat source. Okay, so we've let the sample cool for a while. Part A, the 9-benzyl fluorene. We're going to transfer it to another beaker and prepare it to filter it with suction. Add a little bit of water to help us transfer it. This is quantitative, so we want to get most of it out that we can. Okay, it's pretty good. Now we just want it to sit for a few minutes. You might have some of the product precipitating out of the solution, and it will add to the amount that we recover. Okay, now we're going to go back to part A. Filter the product with the liquid and let it suction filter for several minutes to help dry it. So we want to always start off with a wet filter paper. We let this solution sit for a little bit. Depending upon the pore size of the filter paper, it might take a little longer to filter this material because of the particle size of the product. So this is the remainder of the solution from part A. We've collected quite a bit of precipitate. We'll just let it suction dry for a little bit. A few minutes. Pretty much it. Our two boiling chips stayed behind. So we've let this dry under suction filtration for several minutes. Turn off the vacuum. And now we want to remove the product. This is part B of the Benzyl Fluorene. There's a lot of stuff here. A lot of good product. Now we want to dry this in the oven and then weigh it and come up with our mass and our yield. So this is the collected product that we obtained from part B. We let it dry under vacuum filtration for several minutes, and now we're going to put it into an oven at 100 degrees C to hopefully get it dry enough to get our mass, and then we'll calculate our percent yield. Okay, we're going back to part A. We just finished the suction filtration. It took a little longer because it seemed to clog up the pores in the filter paper a bit. So now we'll remove it. We've got a lot of product. It's still wet, but we'll dry it for a while in the oven and get our weights and calculate the yield. This is at a reduced temperature of around 60 degrees. As it melts about 70, 74. Now, part B was removed from the oven, and we have a mass of 48.3805 grams. That's the weight of the watch glass, plus the filter paper, plus the product. Okay, after subtracting the mass of the filter paper and the product from the mass of the watch glass, we have a weight. And now we have to deduct the weight of the filter paper. And you can provide the mass of the product. The mass of the product will be used to calculate the percent yield, which is based on the theoretical amount of fluorine that we started with. Theoretical, and this will be the recovered amount for part A. Keep in mind that the expected yield will be between 30 and 70%. If you don't obtain that or you're out of that range, write that in your formal report and define why you're probably not in that range, if you're not. Part B. We deducted the weight of the filter paper and the product from the weight of the watch glass as we did in part A. And we have the mass of the filter paper, and you provide the mass of the product. As in part A, you calculate percent yield based on the original mass of fluorine that we weighed. So mass divided by mass of fluorine, which is theoretical, times 100 will give you the percent. Our expected yield between between 50 and 90%. So if you don't get that value, that's part of your error analysis.